those ladders were big enough to scale the wall almost perfectly to within like half a foot. And all of that is based off photos. And I just find that to be extremely fascinating in the 1950s. Of course, what happens is after the wars, the tech and the technicians come home. These are people who've had a chance to work on it privately in the federal government, and now they're home and they're bored. And so what do they want to do is they want to recreate these moments and maybe use this new technology to earn an income or just to have fun. And so this is a short video here. We probably won't watch all of it, but I wanted to make sure that it was demonstrated here. Just exactly sort of what that tech looked like when it started to come home and being used in a sort of a hobbyist type of manner. At the moment, there's not a lot of iteration on the plane shapes. These are very traditional plane shapes. And this hobby is actually for people who had some disposable income because these parts and pieces weren't exactly super cheap. But I mean, it's just fascinating to see them work on it. These are the mechanics that worked on the planes in the military and et cetera. But there you can see, you know, it's very boxy, very basic thing. They're not super concerned about aerodynamics or longevity. They liked seeing them fly and getting them off the ground. You can see the Chevy Bel Airs there, noting the time frame. But this really seemed to spark an interest at home for what was going to be possible with the emerging technology here. And all of these planes, by the way, there were no lithium ion batteries. None of that stuff existed. This is all by gas. And here's a hand launch, which didn't go so well. And then you have another hand launch, same plane. This time it did go well. So I found that to be extremely interesting to find the footage of it. But basically, following the early years of the RC, we needed something to move things forward. The stills that you see here are from the other side of the pond. This is British Aeronautical Society. Very similar designs, similar issues. Basic aviation was not a problem here. These were just basically hobbies and toys at this point. But we still had big issues. And those issues were energy. So what we needed to solve that is the battery and then the iterations that would lead to lithium polymer batteries, which most drones currently use. Control, previously it was a human moving the sticks there. And the iteration of a personal computer was critical to removing human error and allowing you to do autonomous flights in some cases. And then cost-efficient parts. So the rise of plastic and small, again, personal computers, but silicon chips and these small devices, these small ICs, which could handle many different calculations at the same time. The cost of those went way down. And that's sort of what the industry needed, but didn't have at the time. They didn't really have the right energy. They didn't have the right control. They didn't really have cost-efficient parts. It was a hobby. It was expensive. Very few people got into it. However, innovation largely crawled and struggled until the Vietnam War. And then in February of 1962, the Air Force granted a $1.1 million contract to Ryan Aeronautical to produce a UAV for aerial reconnaissance. And then Ryan eventually became Northrop Grumman through a series of acquisitions. Found that interesting as well. This is the first prototype that Ryan Aeronautical came up with, the Lucy Lee. I do not believe that this was ever used, but they started here. The second model, which was a 147A, they added a plug here, a fuselage plug, and added 68 gallons of fuel. Again, we're still doing like piston engines here to fuel these. It had a new nose, which contained a camera from the U-2. And this is an important point that we'll get to. And then also I thought this would be fun for everybody to see. Holloman Air Force Base was the first place that it was deployed. And it came underneath the wing of a DC-130 Hercules. So New Mexico has a long history with drones and drone use. This is the camera that was in the U-2 stealth reconnaissance flyer. It's the Hicon 73B. It's 859 pounds. It's 7 feet by 5 feet by 3 foot 9 inches. 36-inch focal length on the camera. However, at 65,000 feet, it was capable of resolving 2.5 feet. Just unbelievable resolution at the time. And this is not the first iteration of this particular camera, but this is what they ultimately ended up using for many, many, many years. And I do want to point out, if you can see the cursor, this is the camera aperture here, and that's that 36-inch length. You see the angle here, the image would be reflected off and then over onto film. And then over here on the right, you can see the big barrels, which would hold the film or the 2 plates. This particular camera setup can be rotated for oblique images. Very interesting. So that went on for another decade, mid to late 70s. The Vietnam War and things ended. But then the Israelis pioneered battlefield UAVs in the early 80s for their operations in the southern Lebanon area. They designated these as combat surveillance or tactical reconnaissance UAVs. Their intent was not to deliver payloads or armaments. It was reconnaissance, taking pictures. This particular model here, you can see the iteration now, it's 84 pounds. It is 12 feet long. The payload, excuse me, capacity up to 84 pounds. The gross weight, 350 pounds. It is a 1-piston engine, giving it 22 horsepower and maximum speed of 109 miles per hour, 7 hours and 30 minutes of endurance, or that's how long it could stay in the air, and a service ceiling or an altitude maximum of 1,500 feet, 15,000 feet. And then I'm sure you're all familiar with this one. This is the next iteration. It's the Predator drone, first introduced in 1994, retired in 2018. Both these pictures are from 2007, the Wikipedia article on the Predator drone. The one on the right is the one I think is most interesting. It's starting to coalesce the iterations done so far. Now you have video, image, as well as a map, and then controls. If you've ever seen this is called the Coffin Command Center. It's basically a Connex structure that they put these pilots in, and it's air conditioned, and they sit in there for hours, 8-hour shifts, piloting these things. They claim that it's retired, and I can neither confirm or deny that, but they certainly are not done using drones. So whatever their current usage is, I don't know, and that's referring to the US Air Force, of course. So now we come to the modern age of photogrammetry drones. The biggest highlights right now, here and now, are that you are getting a system which controls the function of the drone at every single stage. You're not getting parts and pieces. We now have FAA regulation and certification, which means that there is some accountability and some standards which we can rely on. You can integrate these with traditional tools. This is more speaking towards the survey side, where you can use RTK or GPS to position your data. And then integration with powerful software. A lot of these drone companies focus a lot of their time on their software, and it does show. DJI, for example, has a very clean user interface. It might be a little confusing from time to time, just as an example. And then approachability and usability by nearly every person. You do not have to be a trained and certified photogrammetrist to use a drone in this day and age. You do not have to be a mechanic to use a drone. So some pretty great highlights here. And these are just some examples of what's out there. This is not comprehensive, but you have DJI Phantom there. You have a Matrice type. You have a custom made plane. There's an Intel is in there, Data Hawk, Dell Air. And then at the bottom, you have the Wingtra and then the SenseFly fixed wings. So why did Vectors Inc., a company focused on land survey, choose to pursue drones? Well, the main reasons are that we recognized a growing trend towards UAVs, and our customer base demanded it. There were people asking, what about this? Should I use this as a tool in my toolkit? And in 2017, we recognized it as a pivotal year for drones. There was enough data points there and enough interest to say, oh, this is actually starting to pick up. And then finally, we had the personnel to handle it, or I mean, I volunteered for it because I find these things interesting. So which did we choose to align with and why? As you saw in the previous graphic, there are lots of choices out there. And today, this very day, October 14th, there are lots of choices out there. For us, we have a history with working with governmental agencies as well as the private sector. We needed to be able to pick a unit that was going to address both markets and be Blue UAS compatible, which means that you can use it on federal projects. We needed the product to match our core values, which are reliable, accessible, and authentic. And we needed to make sure that our customers stayed productive with these products and weren't spending too much time fixing, repairing, or waiting, or whatever it is. So in 2018, we partnered with SenseFly to distribute the EB platform. And then in 2020, we partnered with Wingtra to distribute the Wingtra 1 platform. So let's take a quick peek here at the SenseFly EBX. The EBX is the newest model of fixed wing from the company SenseFly, who is a part of the parent group. The payloads are interchangeable, but their two most impressive are the ones shown here. It's the SOTA 3D and the SenseFly Area X. The SOTA is a 20 megapixel camera, but the SOTA 3D puts it on a gimbal. So now you can take oblique shots as well as nadir shots. And then the Area X is an APS-C type sensor. So it's more like a DSLR. It's a 24 megapixel, but just nadir shots. It's a single prop fixed wing. It has a linear landing. So it comes down like a jet, like a passenger plane. 2.5 pounds, 25 to 68 mile per hour cruise speed, 28 mile per hour wind resistance. I can tell you from personal experience, it's better than that, although you should not fly in winds better than that. 59-minute maximum flight time, which you can extend to 90 minutes with a waiver and the right batteries. 1,100 acreage nominal coverage. Again, all these are in the perfect conditions, which we'll get into. New Mexico never offers you the perfect conditions. Spoiler. And 1 centimeter ground sample distance, which is going to be 3 by 5 absolute accuracy with RTK. This unit is hand launched. So you are the one starting it and basically getting it into the air. And then let's take a quick peek at what that looks like.
Hi, my name is Andrea from SenseFly. In this tutorial, I showed you how to...
I may just mute her and get to the meat and potatoes here. So you do your pre-flight check, of course. Did I pause it? I'm sorry. You do your pre-flight check. You check for the wind. You do want to launch this into the wind, which is what she's indicating. And then you put your hands at the shoulders of it. The propeller is basically at her belt line there. And so what she's saying is you will give it a shake to start it. And then after it's done its startup, you're going to tilt it to roughly 45 degrees. And then you're going to give it a little bit of a shove into the air like that. in order to help it go. And then here's the actual. So shake to start, prop spin. You wait for the LED indicator, which is difficult to see in this light, but then you tilt it to about 45, like that, and toss. And there it goes. Now, some of you in the audience are EV owners, and you can surely understand what I mean when I say that I get a knot in my gut every time that I launch the EV. There's just something about having the prop next to you that's a little, it makes me a little nervous. I've had great success, don't get me wrong, but it is intimidating the first time, and it's intimidating the 100th time. So it's what I would see as one of the possible pain points for this particular model. And then I just wanted to point out here the SOTA 3D again, 1-inch sensor. Your pixel size is 5400 by 3600 pixels. And then most importantly here, you get 2 oblique and 1 nadir photo every time instead of just the 1 photo. What this will do is create wonderful 3-dimensional models versus just flat, because now you're going to get the vertical surface because of the oblique picture. So let's jump into the other one. The other choice that we had is the one that we chose was the Wingtra 1. And this iteration happened, I think, partially with some of the help from the guys that left SenseFly early on and came over to Wingtra and brought their innovations and their ideas here. So the biggest thing here, besides these points, is the hands-off VTOL takeoff and landing. Very, very important for reasons we'll get into here in a little bit. And down at the bottom, on the bottom graphic, you can kind of get a sense for how it goes. So they're taking off from a boat. The VTOL goes up to a pre-described height and then converts into the plane and goes and does its mission. In this particular slide, these folks were using it, Murdoch were using it to track sea cows or manatees. And they could do that because of the high resolution camera and because of the ability to launch and land from unique places like a boat. The landing size in confined areas as small as 2 meters. So 6 or let's call it 7 feet by 7 foot square. So on boats or on roads in between forest lanes and things like that. Because it lands on its tail, the payload is never really at risk of being damaged. Accidents happen, everybody knows that. And the payloads themselves, you can see are, quality brands that we know: Sony, RedX, Altum. The big bad boy of this particular unit is going to be the 42 megapixel Sony RX1. Huge, beautiful images, very, very crisp. But you can also go down to the 20 millimeter, 20 megapixel APS-C types there. We do also they offer multispectral and then multispectral and thermal as well for NVDI mapping or plant health, et cetera. The bundle in a Wingtra 1 is going to look something like that. You're going to get the kit itself, telemetry, the controlling unit, the payload box, and then a backpack for carrying it. But what are you going to do with the drone? Right? Let's say that to this point now you've decided, you've chosen it, and maybe it is one of those two, maybe it isn't. What kind of work can you do with it? Right now, the data is unclear. But what I have here is from 2015 from Business Intelligence. The majority of services offered were aerial and photogrammetry. Aerial photography and video. Second is survey, mapping, and GIS. And then the middle graphic there, top industries using drones. Number 1 is going to be for photography, videos, and things like that. Number 2 is real estate, which I'm sure you've seen. Number 3 is utilities, and 4th is construction. 5th is agriculture. And as of 2018, when I first made this presentation, this is a revision of that first one, there were 95,000 FAA certified. But as you note, January 2021, the estimate is twice that amount of pilots. 1 in 10 companies surveyed uses drones in some way. 92% of those who use them saw a positive ROI from the use of their drones within a year, with construction and engineering being the largest industry adoption to date. However, initial company reaction to drones, 51% say that it was easy to get people to buy in. 47% said there's usually some sort of pushback. That is absolutely standard. 50-50, right? It's America, 50-50. And then once the drones are in place in your company, there's an important note here. Drone activity is outsourced to external companies. 20% of flights are outsourced. 16% of data processing is outsourced. I would suggest that that number is higher now. And data analysis, 23%. I personally don't want anybody analyzing my data, but 23% decided it was okay, almost a quarter. Some of the best places to use it: construction, mining, and aggregates. Your common outputs are going to be 3D, ortho maps, images, video. Public safety is going to look for ortho maps, video, and high resolution stills. Transportation is going to look for images, videos, 3D maps, orthomosaic maps. Energy is going to mostly look for aerial thermography. Telecoms are going to look for videos and images for inspections, right? But keep in mind that the FAA is changing laws constantly. And they're still figuring out how to deal with this huge rise of pilots and all these people going into this airspace. They are definitely getting better at it with every single new amendment. But again, last time we looked, there's over 200,000 FAA certified pilots in the United States. So recouping your investment, now that you have a plan of where to go, you have your drone, you've decided where you're going to go and attack, what market. This data, again, is from that business intelligence report. Average hourly rate by industry, if it's in the oil and gas industry, that's your maximum output. I realize that New Mexico is challenged by oil and gas at the moment. And then there's mining as second, survey, solar, et cetera, et cetera. The other thing to keep in mind is the hourly rates based on travel area. How much do you have to travel? Can you increase your rates by that? You should, because that's good business. Median hourly rates by certification. This is pretty interesting. You can see that the GIS certification is among the highest, next to real estate for some reason, can charge more, and then agronomists and GIS. Surveyors are not the top. How about that? So general guide for estimating job costs, you should keep in mind your travel, what insurance coverage that you have, what industry are you working with, what deliverables do they want, and the quality. That's a given for any project that you do. Your level of expertise, do you have a certification or professional license? Pricing per acre could go in there, and then maybe the market value or the return on investment for the customer. All these things can help you decide a price point for bidding projects. But more importantly, the PR effects and recruitment in the 2020 era are pretty interesting. In 2017, here on the left, you can see older adults are less accepting of drone use in a variety of venues. That's in 2017. Public perception in 2021 now, because of the pandemic, probably 87% like the idea of drone delivery. That's crazy, right? But that is how the perception has changed, and something to keep in mind. In addition to that, recruiting new talent to your teams is going to require some form of drone use. I'm not saying that it's a Wingtra or an EB, but like Cameron Shell here said of Dragonfly, drones, like computers and the internet, will have an impact on society, but 10 times as big. So 100,000 new jobs in unmanned aircraft by 2025 is what the Association for Unmanned Vehicle Systems projects. It's a lot of jobs. So let's get into my tips or my lessons about flying here in the Southwest. I have 5 tips here. Number 1 is the ASPRS GCP recommendations. Absolutely, 100% you should follow these recommendations. You need to know that your data is good and that it's tied to where it needs to be. So for any project that is under 500 square kilometers, 20 checkpoints or ground control points, minimum. If you're getting up above 500 square kilometers, those are massive projects, massive. Not to say they're impossible, but massive. Tip number 2, respect the wildlife. Birds hate drones. It's an unfortunate thing. You invade their airspace and I mean, it makes sense, right? We're talking about Mother Nature here. So plan around nesting seasons. Do not fly above nests or around them. Please be familiar with the emergency maneuvers on your drone if they are available. And if you can, have insurance because things happen and they happen quickly. Number 3, the wind in New Mexico is wild. You don't need to own a drone to know that. So using every single tool available to mitigate it is critical. The things that I like to use are listed on the left here. You have Before You Fly, which is a free app that you can download. Aloft is another free app which helps with airspace. Windy.com and skyvector.com. Skyvector is the graphic on the left with the flag barbs here, and then Windy is on the right. And then a good wind tool. This is called an anemometer. I probably mispronounced it, but this is just tells you what the wind speed is currently on the ground, which will be different than in the air. Tip number 4, turns out that the desert is a tough place to land. So Google Earth is not going to be accurate. Be prepared to create a landing zone, bring a shovel. Be prepared to move your landing site, and hopefully your software lets you do this. Most of them do. Budget for repairs. It's better to expect the damage and not have it happen than to not expect it and have to replace a wing or something else. And then finally, sun conditions matter, but not as much as you might think. So you should try to avoid shadows. Your software will thank you. You should try to avoid partly cloudy conditions where the clouds are directly above and you can see the shadows above the land that you're trying to work on. But don't try to avoid overcast days. Actually, the diffuse light does help in photogrammetry with the software. And don't wait until midday to fly. I know you're trying to maximize and minimize your shadows and maximize your effort there, but the temperatures here, they rise so suddenly that it can often create havoc with your drones. So data and workflows, let's breeze through these real quick. Checking, yep, I have a couple of minutes. So Trimble Business Center, UAS Master. We have 2 softwares that we use. In this software, it is compatible with many, many different types of drones and imagery. They recently introduced something for DJI, but essentially you set up your project parameters, your coordinate system and your units. And then there's a whole new tab here, which allows you to do all of the common things that you're going to do, create a cloud, create a orthomosaic or a raster. You then, once it's in there, you perform a relative and absolute adjustment. So the relative is like a bundle block, and then absolute is where you're tying it down to control points. If you did it well, you can get some tremendous results here. The mean of, this is in survey feet, but oh no, it's in meters, excuse me. So 3 centimeters. You create a point cloud at this point, extract the ground using Trimble Business Center's point cloud classification. Adjust it to a 3D view so you can actually look at it instead of plan view. Sample by intensity if you're doing intensity-based photographs. Then you segment and decimate the cloud because it's going to make hundreds of millions, if not billions of points. And you don't need all of them. Changing it into CAD points. And then once those CAD points are in, cleaning them up, generating feature-coded topo points from the cloud, applying contours, processing feature codes, adding text to it. And then there's Pix4D. Very common software as well. Pix4D is basically 3 steps versus how many steps did I cover here? I'm not sure. Pix4D, the idea is you make a 3D point from 2D key points in 2 different images. And step 1, which is the initial processing, does these 4 things. Key point extraction, then it matches them with other photos. It checks internal and external camera parameters, geolocates them, creates a quick visual, and gives you a quality report. Step 2 then goes into point cloud and 3D mesh, creating both of these things. Step 3 will give you an orthomosaic DSM and BTM if you want it. And then here are some examples. You have your SOTA on the left and your SOTA 3D on the right. It's the same flight pattern, but with 2 different cameras, and you can see you get more data on the vertical surfaces. And some more, Philippines, Switzerland, US highway with the SOTA 3D. Here's the area X, volumetrically, area X is very solid. And then let's take a quick look at the outputs here. Orthomosaics obviously are going to be what you are looking to do mostly with photogrammetry, and a couple of really nice looking ones here. This one I found interesting and fun because it's called Lake Disappointment, which, judging by the orthomosaic here, I would absolutely agree with that. 3D point clouds is also another common. Export, and if you can see the mouse moving, that is a target on the ground in the 3D point cloud. So even those become visible, as you would expect. DSM, digital surface models. And then DTMs, terrain models as well. But for extra credit, once you get into the volumetrics here, you can actually start to create 3D models, which I've seen John Beltran at the CNM program. I've seen him do things like this, which I think is awesome, and just a great use of the technology to get students interested in such. So that is the end of my presentation. I really thank you all for sitting and listening to it. We are located locally here. I am right next to the Balloon Fiesta. Contact info is there. And I guess what I'll do now is I'll pop open the chat window and see what kind of questions we have here. And if I am running into or out of time, someone please interrupt me and tell me. So, okay, let's see. Yep, so here's John Beltran. The SOTA 3D is amazing. That's a firsthand user comment. I totally agree with you, John. I'm just blown away by the amount and type of data that you can get out of it. It's great. Brian asks, how much of a runway does the EB need for landing? It's actually pretty significant. It's probably 200 feet of linear space, which is challenging in most instances. These promo videos that you see are often done on these great lush green wide open areas. That's not reality. That's not the real world. So you rarely ever have 200 feet, both to take off and then to land in. So definitely a challenge for the EB. What is involved in becoming an FAA certified drone pilot? There is a test which they give to those who want to try to become. It's 65 questions. It's been a little bit since I've taken it, but you need to have, I think it's a 75 or 80% to pass it. It is delivered by an FAA certified testing center. I think it's $150 to take that test. And then, oh yeah, I see one just underneath that linked to it, how to become one. Let's see, Carol asks, do these drones get loaded with pre-programmed set of transects, or are they controlled by an operator? In the modern age, these flights are autonomous. You pre-program your area of interest. You decide what your ground sample distance is, what you would like to get, indicating potential waypoints for certain things. And then basically you send that information to the drone. And once you hit launch, depending on which one you're launching, it will automatically fly them because it has GPS or GNSS antenna built in. So it's amazing. Yep, John says we offer 107 prep courses at CNM. I would highly recommend those interested go and take that course. And then Juan says, have you compared horizontal and vertical differences between TBC and Pix4D? Yes, actually, I have a demo set that I flew with the Wingtra 1. It's about 50 images, so it's a small compact set. I'd be happy to share that with you. I did analysis through Pix4D as well as through TBC, and they are quite comparable. The differences certainly are processing time. TBC tends to take a little bit more than Pix4D does. However, Pix4D removes a lot of the control that TBC allows you to have over the data. Those are really going to be your differences. The outputs are quite comparable as well. Pix4D sort of stops at map production or point cloud production. There's not a ton more you can do at that point. You can't really draw on it. TBC would let you then draw on the orthomosaic or on the cloud. So something to keep in mind, difference between those two. And there are plenty of others. These are just the two that I have the most experience with. In fact, if you want to learn more about other processing softwares, I would reach out to John at CNM, John Beltran. Okay, Carol says, can you run through a typical planning setup involved in a drone collect? Yes. So let's see. I wonder if I can do this in real time. I'm not sure if I can totally, but maybe. I'm going to try. Can you still see my screen? Is that still coming through?
Yes.
Okay. So this program is called Wingtra Hub. And in this program, for example,
Hey, Mike, I don't know if you're on a separate screen. We still see your slides.
oh, let me
Can you switch it over there.
then. Yeah. How about this?
There it is.
That's it.
Okay. So the way that this program works and most flight data manager programs will work is you'll get a map and you'll have to decide where your working area is. And that's what this circle represents. This is my geofence. So if the drone goes outside of this working area, then it will return to me. And then you can either physically define here, if you can see that, the black lines. These are basically KML shapes. Define your area of interest. And then from that, what you will do, if I go to plan, actually, if I go to area 1 here, you can see all these little points are adjustable. So I could grab this and move this about and change the shape to match what the KML is. And in doing so, it will change the flight line. So if I change this, you see all this extra stuff now. But if I pull it back in, it automatically adjusts those flight lines. So this would be the planning stage. You would need to decide what your ground sample distance is, 0.6 here. This particular flight at 400 feet is going to get me 0.6 inches per pixel. This is using that 42 megapixel camera. So you decide your area, you plan the area, and then from this point, you would connect your drone up to your controller and load this plan into your drone. And the way that this one would work is our home point over here. From the home point, it would take off towards this corner and start its first flight line here. Then once this is done, it will transition to the first waypoint and continue on to area 2. So all softwares are going to have some sort of variation of this particular model. Some of them may be more streamlined. Some of them may not give you as many options. This particular one also gives you this sort of cross section, I guess, of the terrain that you're following and where you are going to be flying over it. And then some additional data here. So 252 acres, it's 1,360 images, 45 minutes of flight time. Yeah, so that's in a nutshell, it's all about your planning, really, because once it's in the air, then it's basically autonomous. And then once it comes down, that's when you bring it into one of these data processors and check to make sure that the data is strong and that you're getting what you want out of your flight plan. So let's see. Coming back in. Where is my chat box? Okay, that looks like that's all the questions that I had. So again, I really appreciate everyone for sitting in and watching and asking questions. That means a lot. If you have any other questions, please feel free to reach out to me. We are local to Albuquerque. I'd be happy to chat with you about what your interests are, what you're looking to get into. Thanks again.